Welcome to the Math Record. Today we'll be covering the concept of derivatives. This video will cover part 1 of chapter 2 in our calculus class. Okay, let's begin. So, what are derivatives? Derivatives are basically a way to show change. For example, let's say we have a curve, something like this, right? Derivatives at a point will be a rate of change of, of that point on that curve. For math in general, there is a concept called the slope. This is basically the change in y over the change of x. This is usually done with 2 points. So let's say we have a point right here and a point right here, right? So let's say we want to make a slope. A slope would be generally like this, where we have a line that goes through both of these points. Now imagine what that slope would be if we only use 1 point. So instead of using 2 points to make us a line, let's say we just choose this 1 point, and then we make that line right there, right? And this line will be tangent to this graph at this 1 point. So this will be called a tangent line, which will also be the slope of that point of that graph at that point. In our previous video, we talked about the concept of limits. So let's use that concept to derive a generalized understanding of the derivatives. So let's say we have those 2 points, right? And we'll call this point x. The x coordinate is x. And we'll call this a function f of x, right? So if we had to choose this as point A, then point A we could call as x, f of x as the coordinate. So usually when you write a coordinate, it's in x comma y. So let's say this point is like 1, 2, right? So that's the general way to write a point. So if we're just using variables, this is how we're gonna write it: x and f of x. So the general idea is this. Now we have A, that's a point. Now let's choose another point. We're gonna choose a point now that's really, really close to A. But for this example, I'll just choose something super far, far enough, so you'll get a general understanding of how an instantaneous slope looks. An instantaneous slope would be if it's a slope going through 1 point. An average slope would be a slope that goes through 2 points. So on this line, this line will be called a average slope, because it chooses 2 points to find an average slope, which is the slope average of it, in this parabola curve, because they're not the same. An instantaneous would be the one that I showed. Sorry about that. That's B. And we have a point like right here, and a line goes through only that point. So it doesn't go through A or B, and it doesn't go through any other points in this graph except this 1 point. This line will be called the instantaneous slope, because at that instant it's that slope, and that's the general idea. In calculus, this is what we use as referral to the tangent line. So this would be B. For B, let's just call this as x plus h. And h is like a really small number. As I said before, B is just a point that is very close to A, but for this example, I'm just choosing something far enough so we get a visual representation. So if the x coordinate is x plus h, we have x plus h. And then the equation would be f of x plus h. Right? So these are our 2 coordinates, A and B. So when we are finding the average slope, right? I'll just call that AS, average slope. It's generally just the change in y over the change in x, which is the definition of slope. So it would just be the f of x of h minus f of x divided by x plus h, the change in x, right? Minus the x. You see how there's a x plus h minus x? The x cancels each other's out, so this is called h. So on the bottom is h. And that's the average slope. And using this concept, we could help derive or to get the instantaneous slope. So imagine the h is just like some kind of number, right? Imagine the distance between this point and this point is only 1 away. That means h is equal to 1. H is equal to 1. Or if we want it to be like even closer, we'll say h is equal to 0.5. It's only 0.5 away from x. Or if we want to make it even closer, it's 0.01 away to x. You see how the pattern is getting smaller and smaller and smaller? Well, the general idea is that we could use the concept of limits, as we covered before in our chapter 1, to find the instantaneous slope. And that was what it is. So we'll have average, so instantaneous slope, I say IS, would be the limit as h approaches 0. We have f of x plus h minus f of x. Sorry, I'm running out of room. Divided by h. So as h approaches a really, really small number, this value would be some kind of value which we could help calculate the slope. So this would be the general idea we could use. This might seem very difficult right now to understand, but if we apply it to actual examples, it will make more sense. So let's actually try an example. Okay, so let's say we have a f of x is equal to 5x squared, right? This is a quadratic formula. So, quadratic equation. So, if we want to find the derivatives, right, let's just first plug in our first point, which is just x, f of x. So, if we just have that, the point would just generally be the first is x. Well, if you plug in x into 5x squared, it would just be the same thing, 5x squared. Because plugging x to x squared would just make x squared. So this is the general idea. And now let's use the x plus h and f of x plus h. Now this idea is that if you plug in x plus h into x, so that would be 5 times x plus h squared. So this coordinate would be, let's write this over here. We have x plus h as our x coordinate. And if we expand this out, we have 5 times x squared plus 10 hx plus 5h squared. Right? If you expand this out, because that would be x squared plus 2hx plus h squared, and then you multiply 5 to each of those terms. Now we have these two. So we have this, and we have this as our 2 points. Now let's try finding the slope. So the average slope would be if we find the change in y over the change in x. So we have this y and this y. So if we subtract them together, right, we have 5x squared plus 10 hx plus 5h squared minus 5x squared. So the 5x squared cancel each other's out, right? So this and this cancel each other's out, and we only left with this term. So in the top, the change in y would just be 10 hx plus h squared. And on the bottom, we have the change in x, which is just x plus h minus x. So x plus h minus x is just h, right? Because the x cancel each other's out. So we have h. So you see how there's h here and here on the numerator? We just divide that out. So 10x hx divided by h is 10x. And we have h plus h squared divided by h is just h. Let me write this a little bit more clear. Right here, so we have 10x plus h. And that will be our average slope. So when we have a limit, so we have a limit to find the instantaneous slope. So the instantaneous, sorry if I wrote v, that's as. Sorry about that. And instantaneous slope would be equal to the limit as h approaches like a really small number, right? Let's say 0, as h approaches 0, x, 10 plus x plus h. So as h approaches 0 for 10 of x plus h, wouldn't that just lead up to 10 of x? Because h is going to be 0 as h approaches 0. So this would be the instantaneous slope that we're looking for. So if we want to find any single point and its instantaneous slope at any point, then we just use this formula. So if we want to find the instantaneous point at x is equal to 1, if we plug in 1 here, that would be 5, right? So 1 squared, 1 times 1, because it's 1 squared, it's just 1. 1 times 5 is 5. So at 0.15, which gets f of x, our instantaneous slope would be plugging in that x, which is 1, into this equation. So 10x times 1 is just 10. So at 1, 5, the instantaneous slope is 10. So that will be the general idea. So how would this look in the graph? We'll have this. Let's say we have that quadratic. We have something generally like this, a quadratic formula. And we have 1, 5 right here. The instantaneous slope will look like this. So it only goes through this point. My drawing is bad, but basically that's generally how it looks. The derivative at this point is basically finding that slope. And it works for any point. If you choose a point here, 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 or here. It doesn't matter. Any point on the graph will work. It just has to be on that graph. Okay? That is the general idea of how derivatives work. That is as the change in x, which is the h in this case. So as the change in x decreases and it approaches 0, then we can get a equation that calculates the derivative at this point. That basically covers the introduction to derivatives. In the next video, we will introduce the rules for limits and relate them to their derivatives. Thanks for watching, and I'll see you at the next math record.